Welcome. In this video, we will show you our technological approach at FluidOps and how data graphs and ontologies are used for integrating data and how this technology manifests itself in our products. So first of all, let's have a look at the classical way of storing information, which is a relational table layout. In this case, we have an employee to customer relationship and the instance data showing that Tim Jacob has something to do with ABC Limited. In this case, Tim Jacob is the employee and ABC Limited is the customer, and there's a logical context between the two of them. So this information is now converted to an ontology where we store information using subjects, predicates, and objects, and those form triples. So this looks like the following. We have Tim Jacob, which is a URI, or this resource is identified by a graph in the node, serving the customer ABC Limited. Now let's have a look at a little bit more complex example with three tables providing the data sources. So we have a customer overview, a product overview, and an employee overview. Note that these tables have different colors, indicating the fact that they can be stored in different information systems, which form silos which we want to bridge using linked data. So transforming this to ontology, we have the structure. Again, notice the different colors and the fact that the various concepts, or the key concepts like customer, employee, and product are interlinked from one part of the ontology to another, representing different sources in the core systems. Now, this ontology can be filled using the actual instance data. So let's have a look here. So we have Tim Jacob and ABC Limited, Tim Jacob serving the customer, ABC Limited using products, and so on. So little by little, we get more and more information in this graph. So the key point here is the following. Notice that all of the information is represented by subject, predicate, and object triples, essentially forming a link in the graph. Note that links from different data sources indicated by the different colors can interlink and form an entirely graph which spans the entire data sources of your organization. And you being able to browse this information, for instance, going from Tim to ABC Limited to a automation product, without you noticing which original data source that information came from. Also note that data provenance is taken care of in this data model intrinsically. So if you have the statement, Tim Jacob serves this customer, which is gray in this example, this gray color represents the context and indicates which data source that information was imported from. So this is very important for assessing when the information was imported, where the information comes from, if the information is incorrect, where it can be fixed at the source and then re-imported, and also whether the information is trustworthy. Also note that another data source, let's say a green data source, can make another statement saying that Tim Jacob maybe serves another customer or a different customer, and that this is also a great way to represent conflicting information coming from different sources. Classical example would be your configuration management database being a little bit out of sync with the real infrastructure, and there being a different information on how many CPUs the virtual machine has. Last but not least, a very important aspect is the ability in this integrated data graph, the ability to re-import, let's say, the green information. So I can trigger the green data source again. I received the has status, has feature twice, and the has use case triple. So in this case, 4 pieces of information. I can delete them and then just reinsert the new information that I get from the green data source. So this allows me to do point updates without interfering with the rest of the data graph, which is a tremendous advantage compared to a relational data warehouse. Let's have a look at what the system architecture of the FluidOps products, namely the information workbench, looks like and how it leverages linked data to integrate information in your enterprise. So we start out with a single information source, a relational database in this case, which is accessed from the platform, let's say using SQL and JDBC, for instance. This information out of the database, like we've shown in the slides before, is then converted to a graph forming a number of triples, which can then be accessed from the GUI, and there's an access control layer restricting certain users to see certain information. That's a very important feature because as you're integrating data, more and more data, it's very important to be able to control in a very fine-grained fashion which user gets to see what kind of information, especially if it's human resource or financial information. So far this isn't very exciting, but of course now we have the next data source which we hook up, so the next silo we would like to bridge. And notice that also in this case it's a REST XML endpoint, and this information out of that endpoint also is converted to triples, much like the triples from the relational database. And that's the beauty of the graph database. You can quote unquote just throw all those triples in a bucket and they immediately link each other. And you have certain resources which are mentioned by both data sources, which then immediately form these intergraph relationships, or these inter-data source context relationships. The GUI, quote unquote, gets bigger as we can now display more information for a given context. And of course, this allows us to onboard more users. Of course, the same, you can also have these sort of hybrid data integration scenarios where you can even, apart from all of the on-premise data sources, you can also integrate external data. It conceptually doesn't really make a difference. Again, the story continues, graph gets bigger, more users, and more use cases can be leveraged from this data source. Last but not least, it's very important to note that this is not just a consumption and visualization only approach, but the last column indicates two things. First of all, there's a pen, which indicates that users can also enter triples. So users can become data sources, and you can make statements about the things that you have in the data source. For instance, the fact that you are responsible for a certain virtual machine or a certain infrastructure asset. You do this in cases where there is no data source available, or no data source can easily be mapped, or maybe the information is only available in people's heads and not represented in a structured form anywhere else. Apart from the pen, there's also this command line icon and an API at the bottom, which indicates that, of course, we can not only read data from the sources and integrate this information with data from other sources, but we can also issue commands to APIs. So those can be REST APIs, those can be SSH commands, those can be local system shell commands, whatever. And it's always possible for you to put active elements on various UIs and send email, write data back to relational databases, start virtual machines, start up IoT machines, whatever it is that the app wants to do. One last point is that it's also possible for the data to be further enriched by external algorithms. So it is possible to take some of the data in this green layer, feed it through an external engine, which makes some inferences or some computations, and the results of those can be fed back into this data graph as well. This can range from very simple examples like a virtual machine naming scheme, where, let's say, a customer name or a customer identifier is encoded in each VM name, and such naming schemes are quite common, and that allows you to actually materialize this information that a certain asset belongs to a customer as an explicit triple, and also make it queryable even without knowing this naming scheme. It goes on to linguistic approaches or text recognition approaches, where you can take unstructured text like email, run it through an engine which basically extracts metadata and information, what this text is about and what entities or other graph nodes are mentioned in this text, and you get further information that way. Or you can do statistical analysis using R, or even external services like the Watson service from IBM. So all of these things are treated by us as classical data sources. Okay, now let's move on to the user view. and the access control concept. So we have the same picture again with some colors here. The first user group might be, let's say, a first level support team, which gets a certain restricted view. So you have some GUI elements which are active for that user group. You have some dashboards which are exposed, and you have some access control. And that use case might allow the first level support employee, while he's on the phone with a customer, to get some relevant information about the customer. There can be another user group which has a completely different view. Let's say this is someone doing capacity or resource planning, wanting to have a very broad overview over the data instead of just finding out about a specific customer's items. That person might want to get an overall aggregated overview of consumption or things like that. So that is possible. Or the next user group could be someone in the self-service portal, maybe managing assets that were deployed through a self-service portal and issuing commands, starting virtual machines, resetting passwords, things like that. So the next thing we're going to do is we're going to look at the live system, and we will integrate some data sources and look at various views that are filled with the data and how we can add additional data sources to maybe bridge some gaps and find out things we weren't able to do beforehand. At this point, a couple of words about what an app is. If you look at this picture, which represents the generic information workbench architecture, it is clear that this architecture is very generic and is applicable to really all use cases. So that's why we opened up the Information Workbench software development kit for partners to write applications for various different use cases, be it life sciences, fraud detection, data center management, etc. And such an app basically consists of adapters at the bottom, which can connect to various data sources, which you typically find in a certain domain. It consists of an ontology, so basically vocabulary, how you express triples, what kind of types you have in such a system. An app contains access control rules, so which user roles for a certain application are allowed to execute which commands, and which user roles are allowed to see what dashboards and are able to issue which queries. And there's a number of dashboards which are assembled in complex GUIs, which are interlinked and can be used with active elements, self-service commands, etc. And all of these assets together combined make up an app for a specific use case. And now we'll look at the eData Center Analyzer from FluidOps. That's an app which gives you data center transparency, and we see this app in action now. Here we see the home screen of the eData Center Analyzer. And the first thing we need to do, because you see that obviously everything is empty, there's no data in there yet, is to hook up some data sources. So you go to Settings, and then we add an infrastructure provider. In this case, we will choose a VMware infrastructure. And choose a, so we enter IP address, username, and password, and we choose a poll interval. And now the provider collects this information. So here you see the fact that there's an app behind this because this provider is part of the app, and there's no need to do any kind of mappings or do any kind of low-level commands. It's basically all out of the box. So the second thing I'll do is I'll add a NetApp filer. Again, enter username and password, and then submit this request. So the product now collects this information. We see that this vCenter provider already completed. Usually, well, it only took 11 seconds to collect. Okay, the NetApp provider is also done. Took a little bit longer, 1 minute and 20 seconds. So now I can go back to the homepage we looked at earlier, and we see that various information is provided. There's some jobs, there's some memory, CPUs, and so on. So the usual suspects that are being displayed. I can now look at the compute dashboard. So again, this is These are things that are built into the eDataCenter analyzer. And I can follow along this vCenter, for instance, go to the cluster, and from the cluster, of course, jump to a virtual machine. And so all of these dashboards are built into the product, and the app eDataCenter Analyzer determines, using some of these dashboards, which are built using a collaborative mechanism, determine how the graph information is being displayed. Looking at the NetApp side, we also have a storage overview, and we can see some information about the individual filer. Of course, we can have multiple filers in here as well. And we look at aggregates and volumes and LUNs, etc. So now, of course, the key question is, where do I see the graph in all of this? So we have a new widget available, which we're going to use to demonstrate, first of all, how the VMware and the NetApp information is interlinked, and how we can create relationships to customers, and the fact that we will actually need an additional data source for this. And I hope this illustrates the fact how the product and the data integration works. Okay, I'm on this Graph Explorer page. And the first thing I need to do is I need to add a couple of nodes to my canvas. So I'll use the graphical query editor to look at all of the storages. In this case, I only have one. And I will also add all my clusters. Oops, okay, remove this one. Okay. And now I can select clusters and storages, and I can simply do a search to see how they are connected in the graph. So find paths between selected nodes. And it takes a little while. And here we see all of the relationships. So let's examine this a little bit. So we started at, so we have a vCenter 5.5 over here, which has a cluster 5.5. Cluster 5.5 contains the host IO, fluidops.core. From here we can jump to this filer.dev NFS, which is a volume, as you can see up here. And this volume is hosted on the NetApp aggregate 1, which again is on the NetApp. So you see this connection between compute and storage. There's also a bunch of other information here. So we have another volume over here and other hosts, of course, and there's multiple relationships that we can look at here. We can also have a look at this table here, showing that there's a number of volumes, and there's a bunch of other things which we can get rid of because those are relationships that we're not interested in. And I can just remove those to make the graph a little bit more clear. Okay, let's have another example. Let's add one node, which is the host IO. And let's add organization. Which represents any kind of organization, customers or hosters or whatever. So let's examine those two and again search for the paths between the selected nodes. And we only integrate infrastructure information so far. Let's see if a search, well, the search comes up with something, but the link actually goes via persons being responsible. So we actually find a connection between the two nodes via the schema level. That's actually not what we want. So let's have a look here. And we can, so this is the RDF type relationship, which we would like to add to the blacklist. And we can see that the two islands between IO and organization are disconnected again. So let's repeat the search. And now the blacklisted RDF type is not taken into account, and you see that the search doesn't yield any results. And that's quite obvious because we've only integrated infrastructure information, and we haven't really tapped into a CMDB or any kind of other information system which talks about people belonging to organizations or people being responsible for an infrastructure or being customers of an application or a service. So let's have a look at what this looks like. So this is a very, very simple CSV file that we will integrate now. We'll have two columns. One is the asset and one is responsible. So this could be some sort of asset management list where we have the host names here and the user being responsible. So let's integrate this data now using the platform. We go to Settings, Data Sources, create a new data source, CSV, give the name, browse to this CSV file, and we can now look at the preview. You can see that the CSV file is correctly parsed. Save this data source, create an empty mapping, navigate to the mapping, mapping collection, and now we select the table that we would like to integrate, and now we get into this graphical editor. So in this editor, we can create those sentences that we've seen on the slide earlier. So the first thing we do is we edit the subject. So in this case, we assemble the subject URI using this UID. And I would like to change that because the sentence I'm going to make is that the admin is responsible for the asset. So I need to choose the responsible column and delete this UID. Save it, and now we add the actual sentence, and we can say responsible. There's an auto-completion using the predefined ontology. And same thing here, so we delete this and we choose so admin is responsible for the asset. Here we go. Save this, and now we can preview the resulting triples, and we get two statements. Admin is responsible for this host. So that's exactly the data mapping that we want. It looks very much like the table, but we have it in linked data structure, and it can now be easily integrated with the rest of the data. Okay. So I go back to the data source, to my data source here, and I'd simply say create a provider with this mapping. And I just accept the defaults. I can also introduce a schedule in case the CSV file changes regularly. I submit this, and I can now run the provider and check my graph to see if the relationship showed up. So we're adding the host IO again. We're also adding the node of organization. And from here we can just expand organization. So there's a bunch of, and we can just follow along the graph manually now. We can expand the host IO. So there's a bunch of things here. Again, a little too much information, and I will get rid of the volumes and the virtual machines. And I can see that this is my admin here, and if I expand this, I can see that the admin is part of the organization FluidOps, and if I expand this, I immediately have the link. So I can jump from organization to FluidOps to admin to the host IO. And again, by doing so, we traversed information possibly about the LDAP or an LDAP tree, talking about organizations, We had an Excel spreadsheet or a CSV, which we imported using the platform, and we linked this to VMware information. So I hope this overview was helpful for you to understand what's special about FluidOps and the fact that we base our technology on linked data. You saw how the architecture works, what the core principles are, and how this manifests itself in the product. In this case, eData Center Analyzer, or also eCloud Manager, and how you can always extend these products using the platform. So we created data sources, we created mappings, and we used information workbench features to do so. Okay, thank you very much.